Hello everyone. Today I am going to explain about entity relationship model. So there are five types of model as we discussed earlier in the previous video. So first one is hierarchical model, network model, ER model, relational model and object oriented model. So out of the five model, ER model is simple and easy to understand. So it is a simple structure of the model. So here the overall structure of the database about a particular enterprise or a domain. So how we can map the two different entities in real time world, how we can how we can explain the structure of a database model. So ER model is widely used in database design because it is easy and simple and easy to understand. So in ER model, there are three basic concepts: entity set, relationship set and attributes. The first one is entity sets. So in these entity sets, the real world entity, how the any object in the real world entity is considered as the entity set. For example, a faculty in non-university is an entity, a student in non-university is an entity. So similarly, for each and everything we consider as an entity here. So for each and every entity has some set of properties called attributes. So for example, faculty is an entity means faculty has some set of properties like faculty ID, faculty name, faculty phone number, etc. Similarly, student is an entity means student has some set of properties like student register number, student name, student department. So these are all some set of properties used for student. So the values stored in one or more attributes will identify the entity set here. So we will see one by one. For example, faculty ID is an attribute, so the ID contains some value for that faculty. For example, in the next slide I will show you the example of a faculty ID and student register number with value. For this attribute, what's the value we used? And the entity set, the set of people who are faculties at a given university can be defined as entity set of faculty. So if there is only one faculty means we can consider it as a entity, but there are many faculties working at the same university or same departments, means we can consider that faculty as a entity set. And similarly for the student, the entity set represent all the students in the university. The entity set do not need to be a disjoint. For example, we create an entity set called person, can have faculty entity, student entity or both. It may be a faculty or student or neither. So this is the entity set. So entity set is nothing but there are many entities, it belongs to the same type, that is the entity set here. And the next component is attribute. So the attributes are descriptive properties possessed by each member. So as I already told, for each and every entity there are many attributes are there. So for each and every attributes we can assign some values to that attribute. So each attribute of entity set will store the similar information. So here for the faculty, faculty ID, faculty name, faculty department, faculty salary, these are all the attributes, and faculty ID is unique, it is considered as the primary. So there in a department or in a university there are more number of faculties, no both similar ID is used for more than one faculty. So each and every faculty contains only one unique ID. So what are the how we can assign the values to the attributes? For example, faculty ID, so we can assign some number. So this is the ID for that particular faculty, Nanda. So this ID is not assigned for any other faculty. So the faculty department is computing technology. The salary for the faculty ID is some salary here. So faculty number for mobile number is available here. So these are considered as the value for each and every entity. Faculty is the entity and these are all the attributes, and for these attributes we can assign some values here. The faculty ID attribute is used to identify the faculty uniquely because there is possibility for more number of faculty we have the same name, but the faculty ID is unique. So with the help of the ID it is easy to identify a faculty here. Similarly for student, more number of students can have same name, but with the help of the register number we can easily identify a particular student here. So in a database of university may include number of entity sets are available. So if you want to track of faculty and student, the university also contains the information about courses. So for course is one entity here. So that's the reason we told there are many number of entities are available for the university. So again, course is one entity. So under the course, these are all the attribute: course ID, course title, department ID, credits. These are all the attributes we used under the course entity. So in real setting, the university database may keep more number of entity set, but here it's very difficult to show the university database. So entity set faculty and student, this is one entity set. So this entity set contains more number of faculties but with different IDs. Similarly, this is the student entity set, more number of students with unique register number. So this is the entity set. So for each and every student there are different register number here. And next one is a relationship set. Entity discussed, attribute discussed. So for entity set is discussed. For each and every attribute, how we can assign the value, that is also discussed. Next one is a relationship set. How we can relate two different entity. So a relationship is an association among several entities. How we can relate the two different entity, like faculty, that is Nanda is one entity here, and Abhinav, this is the student, and Nanda is the faculty. So faculty, we can associate the relationship with the student with the help of the counselor. So here counselor is the relationship between the faculty and the student. So this is the association. So the relationship specifies that Nanda is a counselor to student Abhinav Ranjan. So a relationship set, again there are some set of relationships are available, same type. For example, here in the mathematical notation, E1, E2, that is upper cases E1, E2 are considered as entity set and lower cases are considered as the relation. So for each and every entity set, that is faculty and student, we can use one relation here. E1 belongs to caps E1, in the sense here there is a relationship between the entity E1, caps E1 here. So this is nothing but the entity set and this is nothing but the relationship. So in this diagram, this is faculty entity set and this is student entity set. The faculty Nanda counsel two students here, 1 and 3, that is Shiva Gautam and Abhinav Ranjan. Similarly, Murugan, he counsel two more students, 4 and 5 here. So this is the relationship. This is the relationship. How many faculties can counsel the how many students. So this is one entity set and this is one more entity set, and the values inside the entities are considered as attributes, and here this is the relationship between the two entity sets. So the association between the entity set is referred to as the participation. The entity set E1 or E2 up to En, that is there are more number of entity participate in relationship set, or a relationship instant E or schema. Schema is nothing but the logical structure of the diagram. So here the named entities in the world enterprise, real world enterprise, that is being modeled. So in the previous example, faculty Nanda, who has the faculty ID, this is the unique ID, and similarly he is the counselor for the student Abhinav Ranjan, who has the register number, this is the register number for that student. So there is the relationship between the student and the faculty is the counselor here. So similarly, the faculty Nanda can counsel one more student. So here there is one more term we used here is role. What is the role done by the entity? The function that an entity plays in on relationship is called the entity role. One more term is recursive relationship set. Here it is nothing but the same entity set participate in relationship set more than once. So we can use the same entity set more than once in different roles. It is nothing but the recursive relationship set. For example, the course already we discussed, there are many attributes are available under the course. Suppose in the current semester a student want to study one course, means the course need prerequisite subject is there, means first he has to complete the prerequisite course. For example, C2 is the current course, but it has the prerequisite course C1, means first he has to complete the course C1, then only it is possible to study the course C2 here. So here we can use the C1 and C2 repeatedly. The relationship set, how we can represent the relationship between the C1 and C2 means C1 comma C2 pairs. That means the C1 is completed, then we can study the C2, but C2 comma C1 pairs are excluded here because without studying the subject C1 it is not possible to study C2. A relationship may also have the attributes called descriptive attributes. So here in the counselor with the entity sets faculty and student, we know the faculty entity set contains some set of faculty and student have some set of students. So when the faculty become a counselor for the student, from which date? So this is nothing but the descriptive attribute. Here we can specify the date. For example, from 3rd January onward, the faculty Nanda become a counselor for the student Abhinav Ranjan. So this is the diagram. So in the previous diagram we know the relationship between the faculty and entity. Here from which date the relationship begins. So the Nanda, he has faculty, he is a faculty counselor for the student Abhinav Ranjan from the 3rd January, and for Siva Gautam Reddy she has the counselor from 2nd January. So from two different counseling date he become the counselor for the student. Similarly for the other faculties there are some set of relationship available between the faculty set and the entity student entity set here. Next one is binary relationship set. So from the term itself it is easy to understand. So one entity set involves two entity set. It is nothing but the binary relationship set. The faculty and student entity set participate in relationship set counselor. So we know this is the from the previous slide itself it is easy to identify the relationship between faculty and student is the counselor. Suppose there is a department counselor, one more counselor is there, means the faculty and student relationship counselor is the one relationship, and the faculty and the student relationship with the department counselor is one more relationship. So two entity sets. Here we can involve two types of relationship sets. So it is nothing but the binary relationship set. Next one is attributes. So we discussed this. So for each and every attribute there is some set of values. We can assign some values to each and every attribute. For faculty ID there is some number, and faculty name we can assign some name. So these are all the attribute values. And similarly for student we can use some attributes and can assign some values to that attributes. So here these are all already we discussed. So the faculty entity may be described as set. So faculty ID and faculty name, department name we can write like this. So faculty ID, so this is the ID for the faculty. So which faculty means from the name itself we can get Nanda, the faculty Nanda, he has the ID this number. An attribute type. So there are many attributes types. First one is simple. Simple in the sense the values cannot be divided into subparts. That is only one ID. So for example, ID is comes under simple attribute type. Again faculty salary, department name, these are cannot be divided into further attributes. So these examples are considered as the simple attributes here. And composite attribute means values can be divided into subparts. So here example is faculty name, faculty address. So faculty name is divided into further attributes of first name, middle name and last name. Similarly faculty address, it can be divided into door number, street name, city name, state name, pin code. Again suppose if there is only street means street number and street name is further considered as it is divided into further attributes. So these types of attributes comes under composite. That means in simple the values cannot be divided into further subparts, but in composite it is possible to divide it into the subparts here. So this is a simple single value and multi value, simple attribute and composite attribute. And types of values, how we can assign the value to that attributes. Single value, so as I already told, only one value can be stored. It is a single value. For example, faculty ID, there is only one ID for the faculty. Date of birth, there is only one date of birth for the student or faculty, anything. So there are here we can use only one value here. In multiple value attributes, more values are possible. So example is faculty phone number. It is comes under multi-valued attribute. Here it is comes under simple attribute. So simple attribute, it contains only single value. Multi-valued attributes contain the multiple value. The faculty has more number of phone numbers. Derived value. So derived value is nothing but we can derive the value from the existing data. For example, if we want to find out the age of a student or faculty, means how we can derive the value means from the date of birth. The date of birth is the existing data, so it is never changed. But age, it can be changed year by year or day by day or month by month, it will be changed. So age is changing here continuously. So we can derive the age from the date of birth, it is the existing one. So it is comes under the derived value. Last one is null value. Null value means we don't know about the value, or we are not declaring the value. These are all comes under the null values. Null values are unknown values. So an attribute does not have a value for a particular entity, non-entity set is considered as the null value here. Next one is constraint. So in that is the entity relationship enterprise logical structure, it defines the constraint to which content of a database must conform. So how we can achieve the constraint, in the sense there are two types. We can achieve the constraint by using two: mapping cardinalities and participation constraint. First one is mapping cardinalities. So in the mapping cardinality, it is nothing but the ratio between the entity set. So how we can relate the two different entity in why or which ratio, or what's the ratio between the two different entity sets, it comes under the mapping cardinality. So for it is mostly useful in binary relationship set. Here we can use the term assign. So there is a relationship, we can assign some work to the two different entity set. Here we are taking the two entity sets. For programmer is the one entity set and project is the second entity set. So the mapping cardinality, these are all the types of mapping cardinality: one to one, one to many, many to one, and many to many. So from the name itself, it is easy to identify for one to one. So this is the programmer entity set. There are many programmers: programmer 1, 2, 3, 4, and this is the project entity set: project 1, 2, and 3. So 1 to 1, in the sense one programmer is assigned for only one project. So here the programmer 1 is assigned for project 1. Programmer 2 is assigned for project 2. So for one project, there is only one programmer is assigned here. So this is 1 to 1. And in 1 to many, one programmer is assigned for many projects. For example, in the programmer 1, he is assigned for project 1 as well as project 2, and programmer 2 is assigned for project 3 as well as project 4. This is, here the programmer is 1 but the project is many. So this is nothing but the 1 to many mapping cardinality. And many to 1, it is vice versa of the previous one. So many programmers are assigned for single projects. So for project 1, this is the only one project, but for this project we can assign two different programmers: programmer 1 and programmer 2. Similarly for project 2, we can assign only. So here in many to 1, it can be associated with any number. So many programmers, or one programmers, or zero programmers. So that is the concept here. So that's the reason here only one programmer is assigned for the project 2. But if we want to confirm the data, so many to 1, in the sense normally we are using many programmers are assigned to a single project. And many to many, last cardinality, mapping cardinality is many to many. Many programmers are assigned for many projects. For example, programmer 1 is assigned for project 1 as well as project 2. Similarly, programmer 2 is assigned for project 1 as well as project 2. That is, project 1 is assigned for the programmer P1 and P2. That is programmer 1 and programmer 2. So this is many to many cardinality, mapping cardinality. So this is the first constraint. Mapping cardinality is the first way to achieve the constraint, and second is participation constraint. So in this participation constraint, again it is there are two participation: total participation and partial participation. Total participation, in the sense the participation of the entity. So here these are all the participants are in the entity project. So all participants are involved, at least any one project here, programmer here, assigned for any one programmer here. This is total participation. But in partial participation, here the programmer 4 is not assigned for any project. So only 3 programmers are assigned for the project here. So here he is free. So this is nothing but the partial participation. Only some entities in the programmer is involved for or assigned for project here. So the same thing here they explained one participation constraint, programmer entity set and project entity set. So here this is considered as the partial participation because programmer 4 is not assigned for any project here, but for the project entity set all projects are assigned for programmer, any one of the programmer here. So this is nothing but the partial participation example. So programmer entity set is example for partial participation, project entity set is example for total participation. In this example it is fully considered for total participation. Here no programmer is free, as well as here in the project entity set all projects are assigned for some programmers here. Here no one is free, so everything is assigned to all entities here. So this is considered as the total participation. So in this video we discussed about ER diagram, that is entity relationship model, entity, attributes, how we can assign the values to the attributes, relationship, so a relationship set, and then mapping cardinality. And under this mapping cardinality there are many types of mapping cardinalities. The 4 types are there, and in participation constraint there are 2 types, total participation and partial participation. Thank you.